Academy of Diet and Fitness.
Chapter 11. Sports Performance and Exercise Nutrition.
Sports performance and exercise nutrition. Sports nutrition is a vital field studying how diet influences athletic performance, recovery, and fitness. The right nutrition boosts endurance, strength, and recovery after exercise. Here are some key aspects of sports performance and exercise nutrition in nutritional biochemistry. Energy macronutrients. Carbs, proteins, and fats fuel physical activity. Carbs are best for moderate to high-intensity exercise, while fats are crucial for endurance activities. Timing and adequate intake of these macronutrients are key for sustaining energy during exercise. Carbohydrate loading. Carbohydrate loading is a dietary strategy that involves increasing carbohydrate intake in the days leading up to an endurance event, such as a marathon. This strategy maximizes muscle glycogen stores and can enhance endurance performance. Protein for muscle repair and growth. Protein aids muscle repair and growth, vital for athletes, especially in strength training. Adequate protein intake, especially post-exercise, boosts muscle recovery and adaptation. Hydration. Staying hydrated during exercise is crucial for peak performance and avoiding dehydration. Fluid intake helps regulate body temperature and supports cardiovascular and muscle function. Electrolytes like sodium, potassium, and magnesium play a vital role in maintaining fluid balance. Micronutrients. Micronutrients, like vitamins and minerals, are vital for athletes' energy metabolism and overall health. With increased energy expenditure and potential nutrient losses through sweat, athletes require adequate micronutrient intake for optimal performance and recovery. Timing of nutrient intake. Timing nutrient intake strategically can enhance exercise performance and recovery. Consuming carbohydrates before and during endurance exercise offers readily available energy. Post-exercise, prioritizing protein intake aids muscle repair and glycogen replenishment, optimizing recovery. Supplements. Athletes often rely on dietary supplements to optimize performance and recovery. Creatine boosts strength and power, caffeine enhances endurance and alertness, and branched-chain amino acids, BCAAs, alleviate muscle fatigue. Body composition. Nutrition also plays a role in body composition, which can impact athletic performance. Proper nutrition can help athletes achieve and maintain an optimal body composition for their sport, whether it be muscle gain, fat loss, or maintaining weight. Specialized diets. Some athletes experiment with specialized diets like ketogenic or high-fat, low-carb diets to potentially boost performance, especially in endurance events. However, the effectiveness and safety of these diets for all athletes remain under ongoing research scrutiny.
Energy macronutrients in sports performance and exercise. Energy macronutrients like carbohydrates, proteins, and fats are vital for sports performance and exercise. They fuel physical activity, maintain energy levels, support endurance, promote muscle repair and growth, and facilitate exercise recovery. Here's how each energy macronutrient contributes to sports performance and exercise. Carbohydrates. Primary energy source. Carbohydrates are vital for energy during intense and endurance exercises. When broken down, they provide glucose, which fuels muscles and tissues to produce ATP, the energy molecule used by cells. Glycogen storage. Excess glucose is stored in the muscles and liver as glycogen. During exercise, the body can access these glycogen stores to maintain energy levels. Improving endurance. Adequate carbohydrate intake before and during prolonged endurance activities can delay the onset of fatigue and improve exercise performance. Proteins. Muscle repair and growth. Proteins repair and build muscle tissue, especially after exercise like resistance training, where muscles undergo microtears. Adequate protein intake supports muscle repair and growth, leading to increased strength and muscle mass. Recovery. Protein consumption post-exercise facilitates muscle recovery and adaptation, helping athletes prepare for subsequent training sessions or competitions. Fats. Endurance energy source. During low-intensity and long-duration activities like steady-state aerobic exercise, the body primarily utilizes fats for energy. Fatty acids are broken down to produce ATP, especially during prolonged endurance events. Energy reserve. Fats are an energy-dense macronutrient, and the body stores them in adipose tissue as a reserve for times when carbohydrate availability is limited or when energy demands exceed carbohydrate stores. Balancing energy macronutrients for sports performance and exercise. The ideal balance of macronutrients depends on exercise type, intensity, and goals. Endurance athletes may need more carbs for sustained energy, while those building muscle may require extra protein for repair and growth. Timing nutrient intake is crucial for athletes and regular exercisers. Pre-exercise, opt for easily digestible carbs for quick energy. During long sessions, carb-rich foods or sports drinks maintain blood sugar and delay fatigue. Post-exercise, carbs and protein aid recovery and muscle repair. Hydration is also crucial for optimizing sports performance, and athletes should maintain adequate fluid intake before, during, and after exercise. Individual nutrition needs can vary based on factors such as body size, training intensity, exercise duration, and goals. Consulting with a sports dietitian or nutritionist can help tailor nutrition plans to meet specific needs and optimize sports performance and exercise outcomes. Carbohydrate loading in sports performance and exercise. Carbohydrate loading, also called glycogen loading, is a tactic popular among endurance athletes gearing up for long events like marathons or triathlons. By bulking up on carbs beforehand, they aim to stockpile glycogen in muscles. This reserves energy for prolonged activity, staving off fatigue and enhancing endurance. Here's how carbohydrate loading works and how it can benefit sports performance. Muscle glycogen stores. Muscles and the liver stockpile carbohydrates as glycogen, a key fuel source for endurance endeavors. When needed, muscle glycogen is converted into glucose, providing energy to power muscles during sustained exertion. Depletion phase. Before carbohydrate loading, athletes typically engage in a depletion phase where they follow a low-carbohydrate diet and engage in intense exercise. This combination reduces glycogen stores in the muscles, creating a state of glycogen depletion. High-carbohydrate diet. Athletes transition to a high-carb diet pre-event, boosting carbohydrate intake to 70% or more of total calories. Supercompensation. Carb loading triggers supercompensation, replenishing muscle glycogen stores beyond baseline levels through increased carbohydrate intake. Delayed fatigue. Supercompensated glycogen stores provide athletes with a larger reserve of energy, delaying glycogen depletion during exercise and preventing premature fatigue. Performance benefits. Carbohydrate loading enhances endurance performance in activities lasting over 90 minutes, like long-distance running or cycling. Proper carbohydrate loading can lead to improved endurance, longer time to exhaustion, and better overall performance in extended exercise. Carbohydrate loading is most effective for events lasting over 90 minutes, such as long-distance running or cycling. For shorter duration activities like sprints or high-intensity interval training, it's usually unnecessary and may not provide benefits. Proper implementation of carbohydrate loading requires guidance from a sports dietitian or nutritionist to avoid discomfort, gastrointestinal issues, or unwanted weight gain. Protein for muscle repair and growth. Protein is essential for muscle repair and growth, making it crucial for athletes and those engaged in resistance training. Adequate protein intake optimizes recovery and promotes muscle protein synthesis, the process of building new proteins in muscle cells. Here's how protein supports muscle repair and growth and benefits sports performance. Muscle repair. Post-exercise protein consumption provides amino acids, the building blocks needed to repair muscle fibers damaged during resistance training or intense exercise. This repair process is crucial for muscle recovery and adaptation, ultimately enhancing muscle strength and function. Muscle protein synthesis. Resistance exercise enhances the sensitivity of muscle cells to the anabolic effects of protein intake, stimulating muscle protein synthesis. Post-exercise protein consumption becomes especially effective in supporting muscle growth due to this heightened sensitivity. Branched-chain amino acids, BCAAs, including leucine, isoleucine, and valine, are essential for muscle protein synthesis. Leucine, especially, triggers this process, and BCA-rich foods can boost the muscle-building response to exercise. Recovery. Post-exercise protein consumption aids recovery, preparing athletes for future training or competitions. Proper recovery time enhances training benefits and prevents overtraining. Muscle hypertrophy. Protein intake, in combination with resistance training, can lead to muscle hypertrophy, increase in muscle size over time. This is particularly relevant for individuals engaged in strength training or bodybuilding. Satiety and body composition. Adequate protein intake promotes feelings of fullness, aiding weight management and maintaining a healthy body composition. Timing of protein intake. Timing protein intake within the post-exercise window, ideally within 1 to 2 hours after exercise, maximizes muscle protein synthesis and aids recovery. Protein sources. Diverse protein sources like lean meats, fish, eggs, dairy, legumes, tofu, and plant-based supplements offer a complete range of essential amino acids vital for muscle repair and growth. Individual protein needs. For muscle repair and growth, protein intake ranging from 1.2 to 2.2 grams per kilogram of body weight per day is recommended, with higher amounts beneficial for intense training or muscle hypertrophy goals.